Whoa! Oh, sorry about it, 30s. Forgot I left that snake there. I am back again for another lesson, and today we are going to be finishing talking about our hormones. We're going to talk about the calcium hormones, water hormones, and sodium hormones. So, for calcium regulation, there's two hormones we're looking at, calcitonin and PTH. These two hormones share a lot of similarities with the first two hormones we learned about, which is insulin and glucagon. For one, neither of these hormones are involved with the hypothalamus, pituitary in any way. And number two is they are both antagonistic. So one is for high blood calcium, one is for low blood calcium. So if you look at your thyroid gland, so remember the thyroid gland produces metabolism hormones like thyroxine. The very back of the thyroid gland, there are tiny glands embedded into it called the parathyroid glands, and they're going to release the hormone PTH, which stands for the parathyroid hormone. The thyroid gland itself will also release the hormone calcitonin. So let's start with that one. So the stimulus for release here, would be increased blood calcium levels. So if you remember from Bio 20, we need calcium to move our muscles. That's one of the jobs that calcium does in our body. So if our blood calcium levels get too high, we need to put that calcium somewhere. So the thyroid gland is going to detect this and release the hormone calcitonin. Calcitonin is going to target three specific areas of the body: bones, kidneys, intestines. Bones, kidneys, and intestines. Now what the calcitonin is actually going to do is it is going to take the calcium out of your blood and put it into your bones, kidneys, and intestines. So for example, the calcium will be deposited into your bones, and then the calcium will stay in your kidneys and intestines. So a way you can think of it is less reabsorption in the kidneys and intestines. This should decrease our blood calcium levels back to normal. This of course will lead to a negative feedback onto our thyroid gland, saying we can turn off the calcitonin and then turn off the effect. So now our blood calcium is back to homeostasis. The other hormone involved here would be parathyroid hormone, or PTH, and the stimulus for release would be decreased blood calcium, so decreased blood calcium. This time it's the parathyroid gland that activates, and it will release the hormone PTH. So PTH will target the exact same things as calcitonin, so it's going to target your bones, your kidneys, your intestines. This time though, we're going to take calcium from these organs, and we're going to put it back into our blood. So now we're going to take calcium from our bones, put it back into your blood. From your kidneys and intestines, so more reabsorption, we're going to put it back into your blood. This, of course, will then negatively feed back to our parathyroid gland, will then turn off the PTH, and then turn off the effect. So like I said, these two hormones are antagonistic, just like insulin and glucagon. Blood calcium gets too high, calcitonin from the thyroid is released, puts calcium into your bones, into your kidneys, into your intestines, brings us back to homeostasis. If calcium is too low, parathyroid gland activates, PTH targets the exact three things: bones, kidneys, intestines, exact same three things as calcitonin. But this time, calcium goes into your blood from your bones and into your blood from your kidneys and intestines. In terms of diseases and disorders, there's not many. I suppose osteoporosis is a lack of calcium in your bones, so your bone's a little weaker and brittle. It tends to affect women a little bit more than men, especially past the age of 60. Cause of this, sometimes if it's hormone related, could be a lack of calcitonin or too much PTH. Another disorder is, I suppose, kidney stones. If you have too much calcium in your blood, they can build up and crystallize in your kidneys. And then also, PTH does help with vitamin D, and we know that a vitamin D deficiency can cause rickets, which really isn't too much of a problem anymore because we do supplement a lot of our foods with vitamin D. Okay, now for hormones that affect your water and sodium balance. So the first one is going to be ADH. So ADH also stands for the antidiuretic hormone. Now notice this is a little bit different than our other hypothalamus pituitary loops. Yes, the hypothalamus and pituitary are involved, but you're going to notice that it's the posterior pituitary. So what does that mean? It means ADH is actually made by our hypothalamus and then stored and released by our posterior pituitary. So when it's time, hypothalamus makes our ADH, Pituitary releases it, and it is a targeted hormone. It's going to target our nephron, it's going to target our nephrons, I should say. It's going to target our kidneys, and what it's going to do is increase water permeability in our kidneys. It's also going to increase your blood pressure a little bit as well, right? You get more water into your blood, increasing blood pressure. This should rehydrate us, and then we're going to have a negative feedback signal up to the hypothalamus to then turn off the ADH production. Now pituitary is not going to release it anymore, and now we're going to be back to being rehydrated. So the stimulus for release is either low blood volume, so low blood pressure, but more often than not, it's dehydration. Dehydration is the stimulus for release. If you're dehydrated, we then have the posterior pituitary releasing ADH. It's going to target your kidneys. It's also going to target your blood vessels a little bit. It's going to increase your blood pressure by constricting them. And then for kidneys, it's going to reduce your urine volume. It's going to hold on to water more, so you rehydrate yourself. Disorders, the main disorder for ADH is a disorder called diabetes insipidus. Often we think of this as water diabetes. It's not the same thing as diabetes mellitus. Diabetes mellitus is your insulin, right? You have a problem with your insulin. Diabetes insipidus is a problem with your ADH. So either you don't make enough ADH or your ADH does not work properly. What happens here? You basically lose a lot of water because you're not going to be holding on to that water. And it can get upwards of 16 liters of urine a day. So for reference, that would be 4-liter milk jugs of urine a day, because you're just losing so many fluids. You're always thirsty, you're trying to replenish them, but you don't have the ADH to hold on to that water, so you're just losing water constantly. Medication wise, you'd probably take something to help you hold on to water and then help out with that. Or you would take maybe a synthetic form of ADH if possible. And our last hormone we're going to look at today is aldosterone. So we kind of looked a little bit at aldosterone when we did the stress hormones, but now we're going to look closer at just aldosterone. So aldosterone does come from the adrenal gland. You would make a little aldosterone during a long-term stress response, but mostly aldosterone is for blood pressure or a decreased volume of sodium in your blood. Remember, we need sodium to use and run our nervous system. So what's going to happen here is there's no hypothalamus, there's no pituitary, there's a little receptor in your neuron right near the glomerulus, which is kind of that ball of yarn filter that filters things in your nephron, and it's called the juxtaglomerular apparatus, or JGA. It's going to release a compound called renin. Now renin is then going to cause another compound to be released, and this is all in your kidney still, called angiotensin. And angiotensin will go up to your adrenal gland, and that's where you're going to get aldosterone. Aldosterone is then going to increase sodium and water reabsorption. This is going to increase your blood volume, your blood pressure, your sodium levels, and also it may cause your blood vessels to constrict a little bit, once again impacting blood pressure. Now, we'll then get our negative feedback happening, of course, where we'll feed back to our kidneys. We will then turn off the renin, turn off the angiotensin, and turn off the aldosterone. This feedback loop does look a little bit more complicated than the others. In reality, the main thing you really need to know is that aldosterone comes from the adrenal gland. And the reason you would make aldosterone is for water, sodium, and blood pressure, right? So reabsorbing sodium. Now, when I say water, it's because when you reabsorb sodium, you also take water with it, right? Because when you reabsorb the sodium in your kidneys, you change the concentration, so water will follow with it. It will also impact your blood volume and blood pressure. So once again, the JGA is about here. That's the little receptor that's going to detect, oh, our blood pressure is a little low, our sodium's a little low. We're going to start to make some renin. Now renin will cause the conversion of angiotensinogen, which is the inactive form, into its active form, which is angiotensin, which will go up to your adrenal gland. Adrenal gland makes aldosterone, and away we go. For disorders, just like cortisol, Addison's disease would be the disorder here because it's an adrenal problem. So if you have a problem with your adrenal gland, it's most likely Addison's, which will affect your cortisol levels and your aldosterone levels. So that is it for hormones. We're now going to move on to the reproductive system. So next lesson, we're going to talk about the structures of the male reproductive system and then get into a few male hormones. So thanks again for watching, and we'll chat soon.